As nuclear power and related technologies promise to make interplanetary trips faster, more efficient, and more affordable, humanity is ready to enter a new era of space travel to Mars, our solar system, and beyond. We could finally be entering the era of nuclear-powered spaceflight according to Elon Musk's most recent technological innovations. If it works as planned, NASA plans on using it for a manned mission to the Moon. Using it, military cargo could be transported across the globe in a matter of minutes, according to the Pentagon's plans. It has the potential to significantly lower the cost of traveling to space, which is being eyed by astronomers, satellite firms, and prospective space travelers. Elon Musk calls it the holy grail of space technology. What is this holy grail of space technology? How does it function? And what can it do for us? Since the birth of civilization, humans have been fascinated by the stars above us in a variety of ways. However, there seems to be a particularly strong current interest in the astrophysics of the cosmos beyond our solar system. This is partially because space agencies are conducting several new scientific studies all around the world. There's the need to create new propulsion technologies that allow for significantly faster velocities than what's now conceivable if we want to send autonomous probes to the nearest stars during a human's lifetime. One of the most promising solutions is nuclear fusion, but commercially viable results have yet to be demonstrated. The biggest obstacle to interstellar travel is a lack of appropriate technology. The fact that the stars are so far away is the fundamental issue with getting there. Proxima Centauri, the closest star to us, is 4.3 light-years away. This is equal to 269,000 astronomical units (AU), where 1 AU equals the average distance between the Earth and our Sun, roughly 150,000 kilometers. Compared to Pluto, which orbits the Sun on average at a distance of around 40 AU, the Sun is over 7,000 times farther away than our solar system's most distant dwarf planet. In that case, how long do you suppose it would take a probe to get to Proxima? The Voyager 1 probe, launched in 1977 to study Jupiter and Saturn, was the fastest spacecraft ever built by humans. It departed the solar system in 2012 and is now moving at a speed of 17 kilometers per second, 3.6 AU per year. It would take about 74,000 years for Voyager 1 to reach Proxima if it were pointing in that direction. From a human perspective, that's not a very beneficial timescale for a researcher to wait for their results. In all likelihood, the space probe's usefulness depends on its ability to return data within a suitable timescale for humans, such as decades or perhaps a century. To be clear, we're discussing travel periods that are around 1,000 times shorter than what Voyager 1 would take to reach Proxima Centauri. Since time equals distance divided by speed, we will need to devise methods for accelerating probes 3 orders of magnitude faster than what is currently possible. How possible is that? Well, if we were to use fusion power to fly, it would be easier. Researchers are coming up with ways to harness the vast quantity of energy released during fusion events and use it to power a propulsion system. The timeline for a manned Mars mission could be accelerated by a fusion-powered spaceship. By lowering the amount of time it takes to get to Mars, this kind of spacecraft could lessen the detrimental effects of radiation and weightlessness. The construction of a fusion-powered spacecraft would be comparable to the development of an Earth-based vehicle with a top speed of double that of any car and a fuel economy of 7,000 miles per gallon. The specific impulse of a rocket engine is used in rocket science to gauge its fuel economy. The thrust unit per propellant unit spent over time is referred to as specific impulse. Conventional chemical rocket engines are limited in their ability to generate high specific impulses. A typical chemical rocket engine has a specific impulse of about 450 seconds, which means that the engine can produce 1 pound of thrust from 1 pound of fuel for 450 seconds, whereas the specific impulse of a fusion rocket is calculated at 130,000 seconds. Additionally, hydrogen will be used as a propellant in fusion-powered rockets, allowing them to refuel themselves as they travel through space. To refuel a spacecraft, we'll simply have to dip down into the atmosphere and suck in some hydrogen from the planet's atmosphere. In comparison to chemical rockets, which quickly burn through their fuel, fusion-powered rockets could deliver longer thrust. Fusion propulsion is expected to enable swift travel throughout our solar system and could enable one-way voyages from Earth to Jupiter in as little as 2 years. And now it appears as though the era of nuclear-powered space travel is about to arrive at last. SpaceX has been working on Starship, a massive rocket made of stainless steel that would be the most powerful rocket ever built. It is approximately 400 feet tall when combined with its booster stage, surpassing the Statue of Liberty and its pedestal. It will also be completely reusable, unlike any prior orbital rocket. Elon Musk's private spaceflight enterprise SpaceX was founded with the goal of making life on other planets possible. In the event of a catastrophic occurrence like a huge asteroid strike, he claims that humans may be relocated to other planets such as Mars in order to maintain civilization. History is going to bifurcate along two directions. One path is to stay on Earth forever, and there will be some eventual extinction event, Elon Musk said in 2016. The alternative is to become a spacefaring civilization and a multi-planet species, which, I hope you would agree, is the right way to go. Elon Musk has frequently discussed his desire to establish communities on Mars. According to him, big populations are necessary for towns to become self-sufficient. To make this vision a reality, we need a capable vehicle that can handle the journey, and that's the gateway for Elon Musk's powerful Starship. The system is made to be instantly and completely reusable. Fully reusable indicates that the main hardware components are returned to the ground for reuse rather than being burned up or dumped in the ocean, as is the case with certain other launch systems. After returning from space, the Starship may be quickly refueled with propellant and ready to launch once more, just like an airplane. The expense of the entire business is decreased as a result. SpaceX has been using the Falcon 9 since 2010, and it's grown to be one of the most important launches for international spaceflight. The next generation, however, is Starship. What purpose will Starship serve? The NASA Artemis program, which aspires to create a long-term human presence on the Moon, will heavily rely on Starship technology. The U.S. Space Agency gave SpaceX a $2.89 billion contract in April 2021 to transform Starship into a lander that can send astronauts to the lunar surface within this decade. The heat shield and flaps required for a return trip to Earth would not be present in the version designed for Artemis flights. Instead, following its initial launch from Earth, the Starship human landing system would hang around in space so that it could eventually be utilized for several excursions between lunar orbit and the Moon's surface. According to Elon Musk, Starship might someday transport passengers to locations within the greater solar system, including gas giants like Jupiter. However, this is still a long-term goal. The groundwork for fusion propulsion is already being laid, in contrast to many of NASA's advanced propulsion concepts, which will take decades to realize. Although nuclear thermal propulsion or NTP systems have been around for a while, they have the potential to reduce travel times and carry more payloads than today's best chemical rockets, which are currently the most powerful. NASA received new research funding in 2018 and 2019 to resume NTP research, with the goal for a test flight planned for 2024. Even Elon Musk tweeted last summer that nuclear thermal rocket for fast transit around solar system would be a great area of research for NASA, seemingly suggesting that NASA could concentrate on NTP development while private companies move forward with more advanced technologies of chemical rockets. Pumping a liquid propellant, most often hydrogen, through a reactor core is how NTP systems work. Fission occurs when uranium atoms separate within the core, producing heat. The propellant is heated during this physical process, turning it into a gas that is expanded via a nozzle to create thrust. NTP rockets are twice as efficient as chemical rockets and more energy dense than conventional rockets. This is due to the fact that lighter gases are more easily accelerated than heavier ones. Unlike NTP systems, which use hydrogen, chemical rockets emit water vapor as a byproduct, which is much heavier. As a result, the NTP rocket may go further on less fuel, resulting in improved efficiency. A fusion-powered spacecraft might also be used to transport humanity to Mars when other technologies are ready. Experiencing Mars and the stars may be as common in the middle of the 21st century as going to the International Space Station is today. In the future, it might even be as simple as visiting our next-door neighbors. Let us know what you think of this in the comments section below.